Hey, ninth graders, we are doing our page of notes today called Systems with Special Cases. So we're going to read the top here. It says, when we were solving equations by graphing, we found that there were 3 possibilities for the number of solutions of a system of linear equations. We're going to relist those 3 possibilities, and we're going to talk about what the corresponding graph looked like in that table right below. So let's start with the first kind of graph that we would see. We would see graphs that had intersecting lines. The word intersecting, it means they cross. So when 2 lines crossed, there was 1 solution. And we would always list it as like an ordered pair. We'd say like 1, 2 or 0, 0. Wherever they crossed, that was the solution. The second kind of graphs that we would see had parallel lines. Now, when a system had parallel lines, they never, ever, ever crossed. If they never crossed, then they had no solutions. Now, the third example that we saw was when 2 lines were the same line. If you had 2 equations that gave you the same line, we said that they crossed everywhere or infinitely. So our answer was infinite solutions. So if they crossed once, it was 1 solution. If they never crossed, it was no solution and they were parallel lines. And if they were the same exact line, it was infinite solutions because they crossed everywhere because they were the same line. So we are going to look at some examples below, and we're going to see what 1 solution, no solutions, and infinite solutions look like when you don't have a graph. Because remember, we're doing substitution and elimination now. So we're not going to always see those graphs. We are going to have to see what it looks like algebraically. So I want you to look at 1 solution here, and these 2 will be normal. They will come out just like we've seen on the last few problems in our notes. So the typical result, if they're graphed, they would cross. So I want you to start by using either substitution or elimination, and I'm going to have you try problems 1 and 2. So get out your pencil, push pause on this video, and do problems 1 and 2 using substitution or elimination. All right, so we are going to solve this first equation using substitution because it's really easy to take this top equation, which says y equals x plus 2, and substitute all of that x plus 2 stuff into the second equation for y. The other way you can think about this is just setting the 2 equations equal to one another because they're both set as equal to y. So when I do that, instead of y equals negative 2x plus 2, I've got x plus 2 equals negative 2x plus 2. Okay, then I can start solving this equation. I can add 2x to both sides of the equation, and I would have 3x plus 2 equals 2. I can subtract 2 from both sides of the equation, and I get 3x equals 0. And lastly, I can divide by 3 on both sides, and I get x equals 0. Now, really careful here. When you do 2 minus 2, it does equal 0. That is a real number. And when you divide by 3, it is still 0. So don't let that get you caught up. Okay, then I'm going to go back to my equation, y equals x plus 2. But instead of x plus 2, I can say y equals 0 plus 2, which is just 2. So I would have 0, 2 for my final solution. On the second equation, it'd be much simpler in my mind to solve this second equation, the second system, using elimination. So we've got 3x and 6x. The way that I could make opposites there is if I took the whole top equation and I turned that 3x into a negative 6x, which means multiply by negative 2. Now you could have done something similar by multiplying the bottom equation by 6, but I'm a lot better at multiplying by 2 in my head, so I'm going to go with that. So negative 2 times 3x is negative 6x. Negative 2 times negative 6y is positive 12y. And negative 2 times positive 30 is negative 60. When I solve this, 6x and negative 6x together eliminate the x's. Y plus 12y gives me 13y. And then we have, let's see, 60 and 34 and negative 60. And when I combine those, I'm starting to think I made an error here. We'll find out. Okay, when I combine those, 34 and negative 60, oh no, we're good. I get negative 26. All right, then I can divide by 13 on both sides. and I get y equals -2. I would like to replace it back into the, let's go with the second equation because I don't have to multiply the y by anything. So I have 6x plus y equals 34, and that would be 6x plus -2. Ugh, I hate that I wrote plus -2, but I'll live. Equals 34. Let's just pretend like that plus sign is not there. I can add 2 to both sides, and 6x equals 36. Divide by 6 on both sides, x equals 6. So my final solution, 6, -2. All right, so those are both one solution, and we can tell in our algebraic solving of these systems because you get a single ordered pair. So if you get an ordered pair, well, we'll sum that up on the next page. So if you get an ordered pair though, there's one solution. I want you to now use substitution or elimination to solve problems 3 and 4 right below. So do your best, push pause on the screen and solve problems 3 and 4. All right, so let's go over problems 3 and 4. I'm gonna do number 3. That looks really simple to solve with elimination because my 2x and my 2x can be opposites simply by multiplying a -1 on the top equation. When I do that, I get -2x minus 2y equals -8. Then I can start combining the x's, the y's, and the constants. Well, 2x and -2x, those eliminate, great. But then 2y and -2y also eliminate. That's kind of weird. Everything's gone on the left side. What is 2 and -8 combined? Well, I get -6. That's making me feel slightly uncomfortable inside my soul because I know this isn't true. 0 does not equal -6. What the heck? Let's look at the next one. On this next one, substitution is going to be the better method. Y equals 2x plus 6. I'm going to replace that stuff into the y place. So I've got 4x minus 2, and then I'm going to replace this stuff. 2x plus 6 goes in the parentheses, equals 8. Okay, let's distribute. And I have 4x minus 4x minus 12 equals 8. So I distributed the -2 to everything inside the parentheses. 4x and -4x. Well, when I combine those like terms, they eliminate. The x's are gone now. So I have -12 equals 8. Oh no, I feel uncomfortable inside my soul again because this isn't true. -12 doesn't equal 8. And sometimes students panic and they say, maybe x equals 8. Don't do that. Don't be that kind of student. If the x's are gone, then let them stay gone. Question mark, exclamation mark. What the heck is going on here? Well, what happened to the variables when you tried to substitute or eliminate in the last two problems? They disappeared. You're gonna see how unconfident I am with my hand or my spelling. I don't think I spelled that right. Okay, so after the variables were gone, were you left with a true or a false equation? That's why we were so confused. It was false. What do you think it means about the solutions? Remember, we had 3 kinds of solutions. One solution, no solution, or infinite. Okay, if you get some garbage answer like this, 0 equals -6 and -12 equals 8, this is obviously going to be no solution. So if your variables all eliminate and the stuff that you're left with is false, that's a no solution to your system of linear equations. Okay, so let's go to the next problem. Page 70, which is your next page of notes. If you need it, pull it out and grab it quick. Try problems 8 and 9. Push pause. You're going to see some weird stuff again. I want you to be okay with it and try to answer the questions 10, 11, and 12 when you're done. So push pause, please. Try 8 through 12. All right, I'm going to start solving number 8. I'm using substitution here because it's already solved for y. So 3x minus, and then I'm going to stick all that 3x minus 7 stuff into the y place. And that equals 7. All right, I can distribute the negative to everything inside the parentheses. So 3x minus 3x plus 14 equals 7. And why did I do? I promise I know what -1 times -7 is. And I promise I know that it's not 14. Let's just Pretend that didn't happen. That should be a +7 because negative times -7 is +7. Ooh, okay, 3x minus 3x. Let's combine those and they eliminate. 3x, take away 3x is 0. So what I'm left with is 7 equals 7. That's weird. But at least it's true this time. Last time it was like false information. Let's try the next one. I'm going to use elimination here. To get the opposites in front of the x's, I'll multiply the whole top equation by -2. When I distribute that, I get -2x minus 2y equals -8. So 2x minus 2x, the x's eliminate. 2y minus 2y, the y's eliminate. What do you do when everything eliminates? You put a 0 there. Okay, 8 and -8 combined also give me 0. What's going on? Okay, so what happened to the variables when you tried to substitute or eliminate in the last two problems? They go away. That's my workaround for trying to spell disappeared again. After the variables were gone, were you left with a true or a false equation? True. It was a true equation. We had 7 equals 7, which is true, and 0 equals 0, which is also true. What do you think it means about the solutions? Well, when you got one answer, it was one solution. When it was false, it was no solution. So our guess here is this is going to be infinite solutions. It's always true. No matter what you do, it's always true. Just like on the last one, no matter what you did, it was always false. So there was no solution. Well, here, everything always gives you the true answer. So it's infinite solutions. So we have 3 types of algebraic results. On the first result, we have like normal answer. So I'm going to write normal answer. Variables don't cancel. So the number of solutions we have there are 1. Okay, the second result you get is a false answer. And the variables cancel. If it's false and the variables canceled, then there are no solutions. Okay, the third kind of answer that we saw was a true answer. But remember, the variables canceled. And this was infinite solutions. So we're going to see those 3 things inside our work and our homework in these next couple of days. 1 solution, no solutions, and infinitely many solutions. Let me know if you have any questions, 9th graders. Good luck on your homework today.